Electrical circuits. What is an electrical circuit? Well, thanks for asking. There's actually two types of circuits, series circuits and parallel circuits. A series circuit is essentially where a type of electrical circuit in which various components are connected in one singular path. The series circuit has the same flow of current throughout all components, and the total resistance is always the sum of individual resistances. Furthermore, the voltage in a series circuit is divided amongst opponents based off their resistance. Most importantly, if one component in a series circuit fails, it causes the entire circuit to stop working. Thanks, Ishan. But what about a parallel circuit? A parallel circuit is just another electric circuit where components are connected across common points or junctions, which are then able to create multiple paths for current to flow through. A parallel circuit, although has multiple paths, always has the same voltage across every opponent. This also still applies if you had a resistor on one path and on another due to Ohm's law. All that adding a resistor to one path means is that the branch will draw less current due to high resistance. However, the voltage across the resistor will be equal to the supply voltage, like the other branches. The current in a parallel circuit is divided throughout different paths, and the total resistance is less than the smallest individual resistance in the circuit. Most importantly, in a parallel circuit, unlike a series circuit, if one component fails, all the others are still able to function. Okay, that sounds reasonable. But how does charge move in series and parallel circuits? And what are some advantages of each of them? And disadvantages, obviously. Thanks for such a great question. This is how charge moves in series and parallel circuits. And here's some advantages and disadvantages of each of them. And how does voltage behave? Well, little Jimmy, thanks for another great question. Here's how it behaves. Thanks for all the information, Ishan. But gosh, there are so many models, like FET circuits and water pumps. Which one should I use? Well, FET circuits is good for teaching, as shown earlier in the video. It's also risk-free, cost-effective, easy to learn and use, making it reliable and efficient due to its accessibility and other factors like I just said. Although, FET circuits does have less simple, just doesn't show the complexity of behaviors of components like wires by adding things like overheating or wire resistance to them, even to batteries. Water pump. It efficiently helps students grasp complicated electrical concepts like voltage and current with water flow. Furthermore, it explains how resistance limits flow, and the simple concepts in the model make it easy to understand circuit behavior. However, it doesn't imply how electrical energy turns into light or heat, and it could also infer misconceptions like current being able to leak out, such as water. In electricity, electrons don't just pile up like water can, and resistance isn't necessarily just a narrow pipe that transfers electricity into heat, motion, or light, involving more complex things not available in this model, like energy dissipation. Sorry to interrupt you while you're telling which model's better, but I don't understand this one concept. What is it? Resistance. Yeah, resistance. What is resistance? And how do you measure it? Like, what different tools can you use? Well, little Jimmy, since it's getting late and I know you have to go since you have to go soon, cough cough. I'll give you a short little summary on how resistance works, how a voltmeter works, and how an ammeter works. A voltmeter is used to measure the potential difference between two certain points in an electrical circuit. An ammeter is essentially a measuring instrument used in electrical circuits that measures the rate of flow of electrons, negatively charged particles, and commonly measures in amps. Little Jimmy, didn't we learn what what resistance does in class. Resistance slows down the flow of electric charge in a circuit by opposing the current. According to Ohm's law, it limits how much current flows for a given voltage. Resistance also converts electrical energy into other forms like heat, motion, in some cases, or light in light bulbs. Oh, resistance in wires, usually. Overall, I believe the standard model is significant for practicing practical skills and having a starting point. PET circuits has the best balance between various skills like building an accurate and deep understanding of electric circuits safely, while also visualizing the process which is normally not visible to the human eye. The water pump model is the least effective due to the various disadvantages and misconceptions it brings, as it doesn't go as in depth as the other models. Now that 3 hours of torture is over, Mr. Adams, you were little Jimmy. And also, cut me some slack on the visuals halfway through the video. I got tired. It's 10 p.m. while I'm recording this, and I didn't have time to, like, pour into the. Yeah. Well, anyways, have fun grading it. Thanks for watching, and goodbye. Honk.